Michael Falloon here with Energy Matters, speaking with John Harju, Associate Director for Strategic Partnerships with the Energy and Environmental Research Center. How you doing today, Mr. Harju?
I'm doing really good. Thank you, Michael. Good to be with you.
Well, thanks for being on. We really appreciate it. Could you tell us a little bit about the EERC?
Sure. EERC is a contract research arm of the University of North Dakota. Our roots are actually previously as one of the energy technology centers under the United States Department of Energy. And our history dates all the way back to 1951 as the United States' low-rank coal research facility under the U.S. Bureau of Mines. So we've been around quite a while.
Could you cover the topic a little bit about the capturing of carbon dioxide with use with coal burning plants, and give us an idea of the positives involved, all the way from economics to the environment?
Sure. Well, there's been a lot of concern about carbon dioxide emissions, especially on a global basis, and while the policy approaches to trying to help mitigate those emissions tend to ebb and flow a little bit. We've been working here at EERC for a very long time on trying to build a business case as to, can we create enough value for CO2 that we might capture at a stationary emission source such as a coal-fired facility, and then be able to take that CO2 that we do capture and put it to a very positive economic use in reservoirs, and in the case of regional here, specifically for the purposes of improving our oil recovery from both our conventional fields as well as the Bakken petroleum system.
Yeah, that's great. Are there any other end users for CO2 other than the oil and gas industry?
Well, there are a number of them out there, but ultimately all of them pale in terms of real uses. I mean, in terms of real substantial volumetric uses, right now in the state of North Dakota, our coal-fired fleet emits a little over 30 million tons of carbon dioxide annually. To come up with uses that are in the millions of tons per year really directs you down this enhanced oil recovery road.
So I'm familiar with some of the bigger conventional fields, like Aneth Field out in the western part of the country. But
hmm
here in North Dakota specifically, EOG Resources, they've done some EOR work, or enhanced recovery work, with natural gas, and I think Hess has had a big project going on. Um, do we have any results out on some of those projects and how much they improve production?
Well, heretofore, in terms of in the Bakken system, the work that's been done to date largely is in the form of fairly limited pilot studies, both in the and limited both by time and by volumes of CO2 or natural gas that have been injected. So all of them at the same time are instructive. And so what I would say is we're, continually moving down a road of understanding. The prior tests have certainly been instructive. They have told us that, okay, well, we can affect the recovery and the mobility of oil in the formation. However, we have some other reservoir engineering challenges in terms of how to make that efficient and how to maintain, control in the reservoir of that CO2, in that we have a very stark permeability contrast between our induced fractures and the matrix, which is, largely impermeable rocks. So, in essence, what we have are neighborhoods that have superhighways running through them, and no entrance ramps from the neighborhoods onto the superhighways. So in essence, that's kind of the challenge that we have, is how do we build those on-ramps to relieve congestion in the neighborhoods where all the oil is, and onto those superhighways, which have been very good at moving oil, but they're not very good at getting the oil out of that matrix, or the neighborhood, as I like to call it.
Yeah, and this may, I guess, one thing I'd like to tell our viewers is when we're speaking about the matrix, that's kind of your longer term production. When they do frack a well, those induced fractures are what they actually crack up in the rock. That's what gives us a bunch of oil up front, but then that matrix will continue to produce, and that's why we get oil out of some of these wells, or should, for 30 to 40 years. One thing that I'm kind of interested in too is this is probably something we're looking longer down the road, because right now they're developing all these fields. We still have good acreage to frack. Would you expect that down the road, when a lot of the acreage is drilled out, that is when the use is going to come to play?
Well, I see it happening actually almost concurrently at this point. I mean, we're actually in the very advanced planning and early permitting stages now with one of our partners to implement a full drill spacing unit project later this summer.
Great.
At the same time, we're at the execution stage on a much more limited pilot injection in an existing unfracked well in the middle Bakken as well. So a lot of this work is going on really concurrent with everything else that's occurring. The urgency of this is, while this Bakken system and the wells that we complete in these tight oil systems have these really fabulous initial productions where we get up several thousand barrels a day of production right away, it falls off very quickly. And the good news with that is we get a very high cash flow in the early stages of one of these wells. The downside of it is 2 years into these wells, their performance has dropped off so substantially that we're very much into a much greater reduction in flows. So the thing with this Bakken system that's very, very peculiar, most of our conventional reservoirs, when we get to a point of highly diminished initial production, we can institute a water flood and essentially sweep water through the formation and carry oil along with it, and get very substantial production. In many cases, a good water flood in a conventional reservoir may go several decades in terms of time. The rocks in this Bakken system are so peculiar in that many of them are what we call oil-wet rocks. And so when we push water through the system, it actually pushes that oil deeper into the tiny pores that we're not accessing, and is largely ineffective in terms of enhancing the recovery. That's why we want to look at something like carbon dioxide or ethane or other higher hydrocarbons that will actually become miscible with that oil, reduce its viscosity, and allow us to recover it more readily, from that rock matrix. So what we see is, compared to our conventional systems where we, get a multi-decade water flood in many cases prior to needing to move to a CO2 flood, in this Bakken system, we see the need to move into it as our secondary recovery method. So, we see that coming much more quickly.
Do you think that it could be used right after the frac job is done to keep well pressures higher for longer? So, you get that drop off, and after that first year, maybe you hook it up right away, and that keeps those well pressures higher and keeps the oil flowing.
Well, one of the things that we're looking at, I mean, it on a one or two well basis, I think our current thinking is that's probably not the right implementation scheme. But when we have greater well density, I think the use of this prior to a very substantial pressure depletion is one of the avenues that we're starting to very seriously contemplate now.
So
yeah, much earlier in the in the performance profile than we had previously postulated.
Okay. Well, one other question too is how difficult would it be to implement the logistics or get the pipe in the ground, so to speak, to actually make this all happen?
Well, it can go pretty quickly. There is an existing CO2 line that runs from the coal gasification facility near Beulah, North Dakota, all the way up into Saskatchewan. And that was built in the late 1990s and has been feeding a very successful enhanced recovery project, albeit in the Mississippian system. So the conventional rocks, not the Bakken equivalent here in the States, but it's been very, very effective. That's a 200-plus mile pipeline. More recently, a CO2 line was completed from north central Wyoming up into southeastern Montana, where the Bell Creek field is, and EERC has been very busy working with the operator of the Bell Creek field, namely Denbury, since their acquisition of the properties from a company called Encore. So, we've been working actually on that effort for about 12 years, and again, the pipeline permitting is a fairly straightforward process, and you work your way through the process and acquire the easements and do the installs, but nothing crazy exotic. We've got about 4,500 miles of CO2 pipeline installed in the United States at this point, and we certainly expect to see a lot more of that going forward over the next several decades.
With the large amounts of carbon that's emitted, how difficult is it to store?
Well, incidentally, over the course of one of these EOR projects, we ultimately irretrievably lose CO2 into that formation, into absorption onto the existing rocks, into the tiny, tiny pores that we're unable to further retrieve that CO2, into residual oil as films. It becomes mineralized. So ultimately, over the course of one of these EOR projects, all of the CO2 that we bring to the field is ultimately stored for the long term in that reservoir. Now, to the oil and gas producer, this isn't something you really like, because your biggest operating cost on one of these CO2 EOR projects is the CO2 itself. Now, on the other hand, if we're looking for a long-term solution to carbon management, that's the good news. Is we're ultimately putting this CO2 into long-term geologic storage. In essence, we're returning the carbon back to where it came from, deep underground, where it's safely stored for more millennia.
So, what does President Trump? What does he mean for North Dakota coal-based power plants?
Well, we certainly think that taking the immediate pressure of the plan that was put forth by the prior administration, and the very severe cuts that were going to be required for compliance, what we think it does is it gives us a window to ratchet down the costs of these capture technologies that would be available to install on that existing fleet. At the same time, it also allows us to build out new technological solutions for next generation power, so that again we can have carbon management incorporated into the production of our electricity with coal as one of our starting points in the design, as opposed to something that you're trying to do very, very late in the game. I mean, in essence, you can look at one of these capture facilities. If you're driving a 1978 automobile and you take it to the shop and everything's, for all practical purposes, been running really well, you take it into the shop and they tell you you've got a $2,000 transmission job that they want you to do to it. You're pretty seriously saying, I don't think I'm going to do that. I think I need to look at a new vehicle. And I think this is one of the challenges with many of the existing facilities in the state and frankly in the entire United States is, you start looking at, maybe $1 billion price tag of capital improvement on a 50-year-old facility. You really start balancing that versus, wow, what's the cost of a new facility? And so I think, what the new policy measures that we're looking at today give us a little bit of an extender on a window to try to get this technology right and try to get those capital requirements reduced and the operating reliability up on the capture side of the equation. At the same time, really better understand how much and precisely where we can put the CO2 to good use in terms of the enhanced recovery operations. Right now, we estimate we're only recovering between about 3 and 8% of the total oil in place in this Bakken system.
And
So
that's
the
gonna.
opportunity to improve that is so huge, and ultimately, as you look at carbon management on a global basis, so if the world were to collectively decide we're going to reduce our carbon emissions by 20, 30, 40%, whatever the number might be, our juxtaposition of our coal resources with our oil and gas resources, I think creates what I would call a very compelling competitive advantage for the state of North Dakota, all things being equal on a global basis. We have economically viable opportunities to actually utilize that CO2 and further our economy.
All right. Thank you, John. We really appreciate you coming on. You were real informative today. We're going to go ahead and take a break. John Harju, Associate Director for Strategic Partnerships with the Energy and Environmental Research Center. Hey, thanks, John. We really appreciate all the information you gave us.
Thank you, Michael. Have a great afternoon.
And you as well.